How often, when working with databases using SQL to query your data, have you actually been thinking about how and where, especially, your data is being stored? Is it being stored in some sort of magical cloud, or is it on your local space somewhere in your file system? That's a perfectly valid question, and this, among others, we are going to tackle in today's video. Hello friends, welcome back to the channel, and today we are going to talk about database page layout, which is extremely useful to understand and to grasp the concept in order to further think about performance and other internal databases actions and aspects that we will cover in upcoming videos. Just a short reminder that this video will be particularly based on PostgreSQL, so not all of the things that I will be talking about will be replicable one-to-one to your database of choice like Oracle or SQL Server, but in general the concept still stands. Your data is being stored somewhere. Your data in terms of the actual storage is in certain aspects similar to what I'm going to show you from the PostgreSQL perspective. So without further ado, let's get into it. So in case of PostgreSQL, all of the data are being stored in PGDATA directory. And this directory depends whether you actually created your database on your local machine or using Docker, or actually you are hosting your database in some sort of a cloud. It can be easily accessible to you, or it will require a bit of a hassle. In general, in this video I will not cover how to, for instance, get into this particular PGDATA directory in the cloud, but if you are working with your database locally or you have access to your server or Docker, you can easily get there by basically querying a path that we are going to show later with SQL where you can find it. And what you will see there is a number of files and folders. What is important is that from PostgreSQL perspective, PGDATA is the actual place where your data resides. So when you have your schema, and in your schema you have your tables, and in those tables you have records, rows, those rows physically are being stored inside of this PGDATA directory. To be more precise, under the base, in most of the cases, folder, and there will be your database folder structure and your database pages layout. Now, I'm not going to go through each and every single file described in PGDATA. You can go to the Postgres documentation, and if you want to get into the nitty-gritty details of that one, you can easily check the documentation. But my most important part was here to emphasize that this is actually the folder where you should look at. But now, when it comes to the structure of the files itself, right? Each of the structure of the files that are being stored in your from your database to your system is actually stored in a array manner. So basically, we are creating pages in terms of PostgreSQL in a heap structure, and each of the pages is basically 8 kilobytes in size. And you can adjust this kilobytes when you are actually building your database, but by default it's actually 8 kilobytes. So as said again, each data is being stored into a page, and these pages are being basically treated as an array of pages by the database. Before we will jump into the actual page layout, what is inside of each and every single page, I would like to talk a bit more about 3 additional files from the PostgreSQL world that are especially useful and handy to understand and to help you with your performance and how actually database deals with certain things. And I'm going to start with free space map, which is actually like a quick and easy way to find information about whether a page has enough free space to fit a new row, or for instance to fit an update to your existing row or not, right? So basically this gives you like in terms of comparison, it's like you are going with your car to parking slots, right? And you have an information that on the level 1, level 2 and level 3, this is the amount of free spots left for to park your car. So this is exactly the same concept here in free space map. So This file gives a database at a glance visibility where is actually, and if there is actually enough free space to facilitate your new row in a particular page or a new update to existing records in that page. Now, the visibility map. So visibility map is actually especially useful in terms of vacuum operation that I'm going to cover in next video most likely, but also it's important in case of index scans only operations. So it basically increases your speed for certain types of queries, again, as I said, especially in considering index scans only, and it basically gives you an information, not you basically, but the database, whether all records from a particular page are visible and queryable, or not all of the records are visible, or for instance, majority of the records or all of the records are frozen. So for instance, in case of vacuum operation, this will be a big addition in terms of benefit of performance and speed. That will basically tell the vacuum operation that it can safely clean up the storage from that particular space. So again, from performance perspective, extremely useful. And last but not least, a file called Initialization Fork, which is especially useful for unlocked tables. And for those of you that don't know what unlocked table is, it's basically a table where we are not adding an information to wall, write ahead log. So we are not adding information about each and every single insert, update, or delete operation on a table. That's why operations on that table are faster than operations on a default wall-enabled tables, because we don't need to persist that information into the wall. However, the culprit with unlocked tables is that basically when the database restarts or crashes or whatever, we are losing the state of that table. So that table is basically cleaned, wiped out. And how this wiped is being done? Here actually, this initialization fork are being used. So each and every single table that is marked as unlocked table it basically is keeping its own init file, initialization fork file. When the database is starting up from like a crash or in general starting up, it basically overrides using this init file whatever state is there, if any, on that particular table. That's why it's basically wipes all of the informations, and it's useful in this specific types of tables. But now we've talked about 3 additional files that are specific for Postgres, but if you will go through your own documentation of the database of choice, you will most likely find similar patterns. But now, page layout. Again, this will be specific for Postgres, but as said before, each and every single database management system has its own page layout that will be similar to this one, not one-to-one, but the general concept still stands, that each and every single page inside of the database is storing your data. And how does it store your data? First of all, from Postgres perspective, you are starting with a page header, and this page header contains 24 bytes of information, among others like information about next wall record, checksum of that particular page, information about the flags, PD_flags, whether this particular page is almost full or still has some space left to accommodate. Then we have lower and upper bounds for free space and for to start the free space and to end free space, basically for the still space that is available for your data to be saved. And then we have some special PD_special information that is basically an offset to this special space that I will cover in a second. And then moving on, we have item ID data array, which is basically a combination of offset and length, 4 bytes per item. And this is actually information to a relation between where your data, where your items, your tuples are actually being stored inside of the page, and its identifier. So as you can see here on this example, identifier 1 is pointing to a tuple, item tuple 1, further down the page, because you need to keep in mind that the actual pointers to the data are being stored first at the beginning of the page, and the data are being saved from the end of the page, and they are basically coming together into a center. And the center, as pointed in this diagram, is actually the free space. Here, all of the new item identifiers are being saved from the start, and all of the new items, new tuples, are being saved from the end. And ending up this page layout fully, we have actually something that is called special space, that normally for normal standard tables with standard indexes is not being actually used, but for some specific indexes, some specific types of tables, this space will actually leverage information for those indexes for database to make it more robust. Now, we've got the theory covered, but it would be important to also understand how does it look from the perspective of the code itself, whether you can actually query this data, how you can get it from the database perspective. So let me get into that information right now. Okay, so we are in our database, right? Let me just make it a bit bigger for you. So, when it comes to the settings of the database, what is a block size, what is the write-ahead log segment size, data directory, whatsoever, right? We can use PG system settings table, and here you can get all of the informations like what is the block size, so currently it's basically 8 kilobytes, what is the data directory, what is the wall segment size. And when it comes to the data directory, as shown in my first slide on the presentation, here is my Docker environment, right, where I'm actually inside of this var lib PostgreSQL data directory, and we also have this directory called base and directory called global, etc. Right? So this is basically the base structure of your database where your files are being stored. So if you are wondering where exactly your data resides, you can always query PG settings. Of course, if you have access to that table, not all of the users have access to that table. So in that way, you will be able to get this information. Now, how to map each and every specific table to actually physical objects, right? So in order to do that, let's actually create the products table, and this is very simple table that has ID, product name, code, some quantity, manufacture date, right? And what we are going to do, we are going to actually insert 1 million records using generate series command from a PostgreSQL standard. And right now we have the table. Let's just check if the data is there just for the sake of this exercise. Products. Okay. So the data is there. So let's say we want to check what is our database name, where is the physical relative path to that data, and we can get this information directly from PG class, joining PG database information. And we are going to leverage 3 basically inbuilt functions, 2, and the third one I've just added for the sake of showing you the pretty size of the information. So PG relational path with the object identifier of the table, PG relation size as well with the object identifier, and this information will give us back that the database name is DC_DB, object identifier is 16,385, name is products, and then the physical relative path is this one. So again, it's missing var, lib, data, Postgres, base, but then you have your specific object ID, etc. And the size of the table is actually 80 megabytes. We've added 1 million records, so it's potentially of that size, okay? Now, what else we can do? We can also check how many pages were actually saved with this insert into operation. So we've basically saved for that table 10,228 pages of data. So as you can see, even though your database, your products table have 1 million records, 1 million tuples with some information inside of the columns, physically it is translated into 10,228 pages of your product's data. Now, if you want to go deeper, so you want to get into the nitty-gritty page layout details, unfortunately there is no way that I'm familiar with that you can do it straight from your PostgreSQL database. We will need here an extension called Page Inspect, right? So in my case, I'm adding that one to my extension schema, but you can just remove this one and it will be added to your public schema as well. So when you have this Page Inspect extension added, you can leverage its functions like page header, get raw page informations, and this one will basically gives us an information about what I've presented from the page layout perspective. So what is from the header actually of the page, right? So what is the lower and upper bound, where is the special indicator, what is the page size, what is the version, etc. And when it comes to the tuples inside of this database, again, we can query heap page items and we are getting each and every single information that basically I've presented here in the slide for PGDATA. This one, right? So exactly this information is available for you. So if you are an administrator or you want to get exactly to the information about the pages directly from the SQL, that extension is basically helpful in your day-to-day work. Now, why it is important in general to understand and to basically grasp the concept of page layout. It doesn't matter whether you are using PostgreSQL or Oracle or whatever else. The better you understand how your data is being saved on the disk, what is behind the tables that you are creating, your DDLs, so what is the structure of the page, the better you can then adjust or improve the performance of your queries. So you will basically know that, for instance, in terms of unlock table, there is something like Initialization Fork, what it does. In terms of the free space, there is something like visibility map, right? You can also get an information how, and this will be covered in the next video, how in terms of vacuum, how vacuum is actually using that information and cleaning up these tables in terms of frequent update delete operations. So basically cleaning up dead tuples, dead rows. So this is especially important from that perspective of the database maintenance. So if you are just making some sort of analytics on top of that, maybe that's actually not that critical to understand. But again, you need to keep in mind that your data is not saved in some magic black box somewhere there. It's actually stored in a physical location, in a physical place. It might not be your computer, it might not be your PC or storage, but actually some cloud storage provider. But still, they are being stored in some physical space. And you can access that physical space and check exactly how they are being stored. I hope that this video was interesting for you. In case of any questions or comments, or in case that I've made some errors here in the video, please let me know in the comment sections down below. Thank you for today, have a good one, and see you in the next video. Bye bye!